Alright boys, hello. The boy got some fresh cuts. I did my exam yesterday. That exam was pretty good. And now I only have 3 days before I have one more exam. So today I can study Saturday and Sunday, and then literally Monday morning I'll have the final exam. The last of all the exams. Now, how will I best study for this last exam? That's a good question, because this is a very content heavy subject. You have to explain, you have to understand more than you do practice. So the thing is, with this subject, I will do one exam, practice exam, and I'm gonna make it my goal that to be able, let's see, now I'm gonna make it my goal to be able to, let me just cross out some of these. Do practice exam. All right. And that's going to be the subject of computer vision. I can delete this area now. But practice exam for computer vision, as well as build out some questions where it will help me explain problems, help me explain concepts. So it's going to be like an explanatory. I'm going to be speaking a lot just to try and understand these concepts better. So I will do the practice exam, understand the practice exam as much as I can, but I will limit it to just today. The rest of the days after today will be reflections, maybe just subtle reviews on the practice exam questions, but then mainly focusing on re-explaining the content after I've reviewed it today, right? And I believe that tomorrow would probably be harder than today, but because it's going to be a lot of recall, attempts to recall, and then the day after I'll have one more day of an attempt to recall, which will be good. And then hopefully by the last day, by the morning, I should have like one final recall before the 8:30 a.m. exam. That should be the way I do things. And hello Nafi, that bet I'll have to do the same for my stat midterm. Fair enough, let's go. Then what I would need to focus on, right, is these next 3 days, what is my criteria? Right, the criteria here will probably be changing even today, later tomorrow. But I want to be able to explain every concept that I am asked to talk about. Okay, explain every concept to a level of detail that shows you understand it, but only verbally. Every concept And the practice exam would give me the most information, and I'll come back to this criteria, I think. Later today, though, I will need to buy. I will need to go out and buy something. And I'll I'll do some of the practice exam now, alright, maybe half of it, and then I'll go buy, and then I'll come back. The thing is, yeah, at most I'll have 15 minutes to do that. I'll say I'll leave now. Yeah, I'll say I'll leave at 10, so we'll make it so that, let's see, timer until 10 a.m. Okay. Alright, and criteria, this is the criteria by end of today. I guess if it's a criteria now, I can just make it this note to do. Explain every concept that I am asked about. Now, in order to do this, I'm going to have to create a list of concepts and written explanations, which can then help me learn these concepts. The other thing I should leverage is, say, the notes that I've written here already. You know, I know where to search each of these different concepts. So if I were just to pick, say, multi-view depth, so explain the unknowns that must be solved in a multi-view depth problem, I wouldn't be able to tell you. Not now. We use a projection model to get the camera matrix using camera matrix calibration algorithm. This will recover the camera's intrinsic parameters expressed as camera matrix. Right. And say a smaller aperture size is what? Increased range for depth of field. Which then I'll have to review. Right. So this is actually good, you know, a good set of concepts to work from, and questioning and then answering. And so I'll probably scan through this multiple times, refining it. I think that would be good. Sarthak, hello man. Is this for a midterm? This is for my final exam, right? So we actually have our final exams in Australia during this period of time in November. So that's what I'm doing here. My hair's kind of like fluffy. Okay, so that's going to be the plan. I'll do first the practice exam. We'll try and get as much as we can for that. And then I'm going to say review the questions collated over the semester. Oh, I'm taking this class in US, just got started with CNNs. Best of luck. Thanks, man. Yeah, have fun as well. Probably going to learn, you're probably going to learn a lot of concepts, maybe. So, watch out. Okay, be able to explain every concept posed to me. Okay, let's just make it that. So let's do the practice exam first. Exam revision. It's going to be a 2-hour exam. Hopefully we can do these problems relatively quickly. 7-page, 120 marks, 50% of the total assessment. Please answer all questions. Writing should be clear, legible. Remove any part of the exam paper. Okay. Answer each of the questions as briefly as possible. Expect to answer the text response questions in no more than 2 to 3 sentences. Yeah, okay. So that means, for this section at least, it looks to be 35 marks. How much is 35 marks in terms of 120? Yeah. So it's more than... It's about a third. About a fourth. Third to a fourth. Methodological questions. And then algorithmic questions. Alright, so there's always going to be an algorithmic questions section. There's always going to be a methodological questions section. Interesting. Alright, so we're going to have to focus on these concepts quite a bit. Okay. If I can't answer something straight away, I'm going to just move on. Okay, that's my policy. I'm just going to move on straight away to the next and don't worry about it. Okay, so short answer, why image border is a problem for convolution? Explain 2 options for handling the image borders when doing convolution. So you could pad the outside borders with a reflection. You could pad the outside borders with a reflection. Yeah, what's the other option to a reflection? There is another option to that. But let's just write something here. So image borders a problem for convolution. Image borders can make image like a vignette. So this is my rough answer there. But B, why is a Gaussian filter preferred to a box filter? Produces less lines in the image, in the output image. Okay, so I'm gonna do this. Suppose you convolve an image I with a filter J, I with a filter F. Then you convolve the output with a second filter G. Which of the following would do the equivalent filtering operations on the image in the Fourier domain? This may be multiple answers. Select all that apply. Oh no, my camera's made me weird. Give me a sec. Okay, I'm back. Oh, sorry, I had to restart my OBS. Okay. So, now, notation, it tells you what the notation is. So, star denotes convolution. Circle denotes element-wise multiplication. Element-wise multiplication. I know that if you do element-wise multiplication of f and g, then it should be convolution on this. So I'm saying it's going to be this one here, most likely. But we'll verify that later. That's just from my intuitive understanding. If two different objects are photographed under exactly the same lighting conditions with the same camera and produce the same RGB values, can we conclude that both objects have the same spectral power distribution? Why or why not? So my instinctive understanding is that this is not, because, well, the question is asking this question as if it is not. So no, but why, I cannot explain. And this is for D. And lighting conditions with the same camera and produce the same RGB values. I would think you could. I think you could, but I feel like I would be missing some point here. Okay, which of the following statements are true of the ReLU activation functions? There may be multiple answers. Select all that apply. I guess, I'm going to say it adds non-linearity. I'm going to say doesn't do that. Faster training helps reduce the vanishing gradient problem. Perhaps. Alright, so I don't know if that's going to be entirely correct, alright, but we'll go with it, alright, because this is me bullshitting at the moment. Yeah. The canny edge detector has two threshold parameters that must be set by the user. What is the role of each threshold? Oh, I can't answer that. So I don't know. Consider the image of a golf ball shown below. Describe two cues that can be used to infer the 3D surface shape of the golf ball Okay, but let me say, so the canny edge detector is one thing that that I need to understand well. All right, canny edge detector. You know, I guess the concept of spectral power distribution is something that I didn't expect to even know about. We may have radio activation, so that's another concept that I need revision on. The Gaussian filter and the box filter I feel like I can understand quite well already. But, you know, since it's a concept, we'll just underline it anyway. Gaussian filter and box filter. Okay. And we're talking about Fourier domains, so this should also be underlined, I reckon. Fourier domain. Okay. Now, if I were to write all these words out, you know, these keywords, I would maybe be able to answer only 2 of those at the moment. Anyway, so methodological questions, though. Interesting. Consider the image of a golf ball shown below. Describe 2 cues that can be used to infer the 3D surface shape of the golf ball. And explain what is computed for each cue. So the cues here are going to be important. Yeah, like a cue. Whoops. Like, I know what you mean by cues, is what I'm saying. Like the shadow, the texture, or something like that, I think. I'm just going to say shadow, lighting. Right, lighting? Texture. Something like this. Assume that you have trained a deep CNN on an image dataset for classification, and you observe that the training accuracy is very high, but the testing accuracy is very low. Name 3 possible strategies that can address this problem. So it's overfitting. I don't know. Better train test splits. Because I wouldn't even know how to answer. So what are generative adversarial networks prone? Why are generative adversarial networks prone to mode collapse? Describe a method to detect mode collapse. So have I even ever talked about mode collapse? No, I haven't ever. Alright, but regardless, mode collapse. Mode collapse is a keyword. And GANs, I guess, is a keyword as well. Deep CNN, I guess, is another keyword. Classification, maybe, maybe not. Compare and contrast the region, merging, and normalized cuts approach to image segmentation. How are they similar, and where do they differ? So the region merging, normalized cuts. I don't think I can tell you. So region merging, normalized cards. How do they differ? Where are they similar? That's gonna be something interesting. So again, look, these are good questions that I will even ask myself. Normalized cuts, region merging. All right. The following questions relate to corner detection. Okay. Would the patch W in the image above be considered a corner by the Harris corner detection algorithm? Well, Harris corner detection algorithm, that's definitely some concept that I need to recall. Why and why not? Justify your answer. In the corner response function invariant to translation, image plane rotation, and scale. Translation, maybe. Image plane rotation, not sure. Scale, not sure. So maybe in addition to providing yes/no response for each property, briefly justify your answer. The architecture of UNet is shown below, yeah. Given an example of a task that is suited to the UNet architecture and explain why. I don't know, right? Why does the UNet architecture contain downsampling stages followed by an upsampling? To learn features, I would assume. To learn features like an autoencoder is what I would think. Why does the UNet architecture contain the bypass arrows that can concentrate activations from the downsampling side with upsampling activations? So this is method. This is what it means for methodological, I see. Used for retaining information. I think that's how I would describe it as of now. And texture synthesis. So how do parametric tensor synthesis differ from non-parametric there, you know what I mean? So parametric and non-parametric. Advantage of each approach? Not sure. Non-paras, not sure. I mean, you'd have grainier, maybe grainier. Results. Maybe. How would you choose an appropriate patch size to correctly synthesize the texture shown below? You know, I would pick in a region of 8 of these triangles. Pick in region of 8 triangles. That's what I would think. Okay, so not bad, not bad. Hello, Matthew. Welcome back, man. I'm just quickly breezing through this practice exam. You know, I don't know that I understand all of these concepts, but this is where I will look into stuff more. And I understand how these questions are laid out more now, which I will have a better understanding after I just finish this specific question. I'll just write it out. Okay, so object detection, briefly explain the difference between region proposal based and single stage object detectors. Region proposal based and single stage, single stage object detectors. The relative, I don't know. In regional project-based, how the region interest differs from a bounding box prediction and how are they related. A bounding box prediction. Why is class imbalance a problem with CNN-based object detectors? A class imbalance, CNN-based object detectors, region proposal-based method. Yeah, okay, so in this section you are asked, okay, so before I am to continue with that, I want to say, you know, what we're preparing for exactly in terms of the exam revision. So understanding the types of questions which show up. Short answer questions, no more than 2 to 3 sentences explaining concepts, right? That's the idea. Methodological questions. How does a concept work? Right. You got to kind of explain the underlying concepts. All right. The vacuum is done there. Give me a sec. Okay. And then algorithmic questions. Algorithmic questions. This is the final section. Being able to explain these well is going to be good for me. And there's only 4 questions for this? Yeah, okay. 3 questions, 4 questions for this. Okay. And then short answer questions. Okay. So, in this section, you're asked to demonstrate your understanding of a subset of the methods that we have studied in this subject to be able to perform algorithmic calculations. Yep, stereo disparity. Assuming two images shown below were taken from a calibrated pair of stereo images. Calibrated pair of stereo images. Of stereo cameras. Each camera has a focal length of 30 and produces 100 by 100 mm image. The two cameras are at the same height and each have an optical center at the center of the image. The image planes of the cameras are parallel to each other, and the baseline, which is 500 millimeters. What is the depth? Distance to the baseline of the indicated point X, which is located at 3130 in the left camera's image and 2930 in the right camera's image. Show your working. Okay, now this is a question that to me seems right. It's you're given numbers and you're trying to solve it. So these are, I guess, the algorithmic questions and what they mean by algorithmic. So solve questions given numbers, right? So that's the so right. What we have is short answer questions, no more than 2 to 3 sentences, explain concepts. Methodological questions. How do concepts work? And solve using concepts. The algorithmic questions. These are the 3 types of, I guess, questions I will come across. Now, epipolar geometry. The essential matrix for a pair of cameras mapping points in camera 1 to lines in camera 2 is this. There are 3 points of interest, this, this, and this. What are 3 points in the epipolar camera 1? Show your working. Which of these 3 points correspond to the point Q in camera 2? Show your working. All right. And then in the following CNN, so this is convolutional neural networks, the input is an RGB image with both height and width equal to 224. The convolutional operation in the convolutional layer is standard 2D convolution. Each kernel has the same number of channels of the input, and the kernel goes through local patches of the input to conduct element-wise multiplication and take sum. FC10 fully connected. Computer size and feature maps output in the layer. Compute the number of parameters and multiplications of them. Yep. Send 2D is replaced with depth-wise separate convolution. And what is the number of parameters and multiplication in the layer? Cool. And then compute the result of performing transposed convolution on a 2 by 2 input on the 3 by 3 kernel. With a stride of 2, with a stride of 1, express each result as a matrix, input, and a kernel. Oh, hello, Sammy. Thanks, man. You know, fresh cuts. Yeah, it's been a while since I got a haircut. I'm now only beginning my revision on this final subject, my final exam, which is in 3 days. So I'm going to be preparing for this pretty hard, and this is the only thing left. So I'm pretty stoked about finishing it all, you know, eventually. So it's alright. We should be fine. I just need to review these concepts, try and explain them well, and I think I should be good. Now, both explain and compute. So some of these problems will require computing. I just got to identify which ones will. Which of these concepts will just require explanations. And if that's all it boils down to, you know, from these questions are mainly, you know, tell me about what something and something does. For this concept, I can just explain it well, right? For every concept that I know, that we've learned, and then also for those concepts which require numerical calculations, I should attempt one sort of calculation and tying it to the underlying concept. So, at the end of the day, like, all of this is just very conceptual understanding. And if I have that down and identify which concepts are computational or algorithmic questions, then I'll be fine, I think. But I will reflect on this again later. But I will say it here. It boils down to understanding the concepts well and identifying which of the course content will be an algorithmic question. Now, an algorithmic question, quote unquote, is just going to be a question that has numbers in it. Yeah, I don't need to write it actually. Okay, but this is all it boils down to. Just got to do it well. All right, and then that means then I'll have to understand all of this. I will look at the solutions to what I just learnt, or what we've just covered. And once I've covered these concepts, I'm trying to just think. So once we've covered these concepts, which is quite a lot already, the few that remain, the few that remain will have to be learnt better. Now, if I look at the exam solutions to this, it should be fine. Just to identify from that, I think. But let's see. Yeah, so if there's anything in this solution that I don't understand, I think I should underline and reference. So, in that case, well, I might then just go practice exam on another page. Just add it here. Hopefully it doesn't overlap. Unlucky, it overlaps. How do I just... Oh, here we go. Okay, now. I'll probably put it to the right. Practice exam solution. Okay. Yeah, that's fine. That's fine. All right. So that's the practice exam solution, right where it needs to be. Oh man, I've gotten frozen again, or hazy. Give me a sec. Why have I gotten hazy? What's causing the haze? What is causing the haze? You live long enough to become the blur. That got deep. Okay, give me a sec. Maybe what I need, I gotta find a way to actually like trigger this to run, but I don't know why it doesn't. Maybe. I wonder if there's a way to just refresh from my camera. Right, iPhone camera. No. Okay, what I'll do is, yeah, restart OBS again. Real quick. And be right back again. It's a bit of a pain, but it's alright. It's unfortunate that I have to do this every time. I don't think it's necessary if I probably get a better laptop, you know what I'm saying? Alright, we'll see. See how long this stays on anyway, but I think I'm just gonna do practice exam, review solutions to practice exam. Now I'm gonna do this after I do buy something. I'll be back in maybe like 30 to 40 minutes. Could take up to an hour, but we'll see. And then by the time I'm back, I should be able to review the solutions to the practice exam, hopefully before lunch. And then the problem is that I'll need to review the questions I've collated over the semester. How would that look like to me? You know, understand these concepts, constantly recall as much as I can during these reviews. Right. But even reviewing the solutions to the practice exam, when I'm doing that, I should also be recalling them on the next question or on the previous question. On the next question. And then the criteria by the end of the day is to have begun. Explain every problem posed to me. That is the optimistic goal. However, you know, I'd be happy with even half of the concepts if I understand half of the concepts posed to me. But I will say optimistically, explain every goal. Okay. All right. I'm gonna be back. I will go and buy something right now, but I'll be back in about an hour. And during that time, I'll put on some music. And let's see. Whoops. New tab. Okay. Actually, that's a bit loud. Alright. We'll come back to it. It's very nice that we're done with this. Damn, I'm so happy that we're done with all of these. Those two exams already. So this last one is just the final stretch. And then the rest is going to be epic. Life is going to be epic. Alright, so I don't need this timer anymore, so I'll just stop it. Okay. And again, remember the things that I will do when I come back. Review the solutions to the practice exam, which won't take any amount of, like, it'll probably be a 2-hour job because I'm relearning the concepts while I'm looking at these solutions. So even still, 11, 12, 1, it pretty much goes to lunch. And then, when we do this review over the semester, this literally could be, the rest of the day. If that's the case, then it could be as much as 4 to 5 hours, maybe, right? So that's the thinking. Lunch is probably just a 1 hour job. And we're good. Okay. Cool. I'll be back. Cool. See you guys in a bit. Okay, so that did take some more time than I expected it would. However, it's alright. We got what we needed, and we're prepared. I'm looking at ads, bro. Not bad though. Riot Games giving me updates. Alright. Alright, now it's time to resume the learning. After I get some water to drink. Be right back. Alright. We're dropping frames. Hope it's alright. Okay. So. Yep. Let me look at these solutions before lunch comes around, alright? Cool. Okay, let's see. Do one monkey type before this. with not the English language, but Python. 5k. I'm gonna do quotes. Let's go one more. Yeah, not bad. Add border pixels. The convolutional kernel will extend beyond the border of the image. The missing values beyond the edges of the image can be filled using options such as zero padding, clamping, wrapping, or reflecting. Wrapping, clamping, I'm gonna have to question what clamping is, because I've forgotten. Alright, so let's quickly look here. This is a good problem just to put in a list of problems. Wait, why is my like stream actually bit rating? Give me a sec. I'm hoping it improves. Ooh, I might know why actually. Give me a sec. Okay. Gaussian filter removes high spatial frequencies only. Right, a box filter affects all spatial frequencies in the image, causing artifacts. High spatial, low spatial. Right. Application in the Fourier domain. Hmm. A summarization of each topic would be somewhat useful. Okay. Oh, hello, Lucas. Nice, man. Well done. I finally got my second exam done. Got one more. I want to build the table. What you call a retrospective. Revision table. No, I deleted the file. Did I? I did. Let me think. How are images represented digitally? RGB something. They're represented as tensors. what is the resampling technique? Nearest neighbor and bilinear. So nearest neighbor and bilinear are the resampling techniques. Bilinear is slower to process than the nearest neighbor. Resampling is used for image scaling. Used for image scaling. Image scaling. Bilinear bicubic. So what's the point of resampling though? Compression? Scaling. Headphones. Hmm. Closest value to sample point. Weighted average. Blurs hard edges. Scary mojo. You're right, man. You're right. You're actually right. I'll do this though instead. You know what I mean? Bicubic. Okay, well, I don't think it really matters all that much. Okay. Okay. So, oh, right. So all of this shit though, never talked about. Okay, what is the camera parameters for image formation? Don't remember. Focal length, aperture size, and lens distortion. Focal length, aperture size, and lens distortion. A small aperture size causes what? Increased range, a depth of field. Increased range for depth of field. I see. Right, it's a smaller number divided by 5.6. So if I just use my... Fuck. I was gonna say let me use my phone for a second. Huh. I did not know you had like direct links. To these photos. Alright. Cool. Regardless. Okay, so reduced aperture gives you a wider depth of view, a greater aperture would not. But why? I guess it's like convolving on each other, right? It's convolving on each other multiple times over. Like, what parts of this should I really learn in detail? That's my problem, man. How do I know? Smaller aperture size causes a larger range of depth. What is the difference between a pixel and a local operator? What is the equation for cross correlation and convolution? How about I merge this all into one file? Get GPT summaries. Should I try? I wonder how possible that is. I want to attempt and see how it goes. One other thing is though, I want to realize Hmm. Hmm. Unite the PDFs. We unite the PDFs after that what? Hyperbola geometry. Off transforms, Harris corners. A 1,000. It's gonna be interesting. This is not gonna probably work. Yeah, thanks. Thanks, Discipline. Yeah. I got a cut just before my exam yesterday. And now we're good. Alright, let's try and see the quality of these flashcards for this basic handout. So, what is an image in the context of computer vision? It should be a tensor, which is a weight, a height, and a width, a height, and color channels. An image is a pattern formed by light falling on a photosensitive surface, such as a camera sensor, representing a 2D projection of a 3D scene. That's fair enough. What is the pinhole camera projection model used for? It is used to map between world points and image points in an imaging system, right? Why do most cameras use lenses instead of pinholes? Lenses focus light rays into a single point, improving the clarity and brightness of images compared to a pinhole camera. Okay. You're getting one next week as well. Goodbye to long hair. Thanks, Rio. Yeah. Got the cuts, got the fresh cuts. How does the aperture size affect depth of field in a camera? The aperture size decreasing will increase the depth of field, resulting in a greater depth of field. So what is a digital image represented as in computer vision? What? Well, it is represented by a 3D tensor, width, height, and channel. Yeah. What are the typical data types for pixel values and their ranges? Double. What is the difference between lossy and lossless compression? What is resampling in image manipulation? The thing that I'm thinking about, man, is what if I started using ChatGPT earlier to make flashcards? Like, this would be so much easier, wouldn't it? Damn. So what is resampling in image manipulation? Why is it necessary? Well, it's resampling creates a new image from existing pixels. Okay, resampling changes the dimensions of an image during resizing. Ensuring pixels are appropriately mapped and is necessary to avoid visual distortion. Yeah, that's right. That does make sense. Flashcard 9, describe the nearest neighbor resampling method. Nearest neighbor resampling method. I guess the concepts there, but say let me think. Given a summary, so given all of these facts, write flashcards using the content from the PDF. Wait, so am I only allowed to... I don't even know what I can use in ChatGPT. There is just so much history. Oh, hello, Jacob Harris. I have so much history. How do I pick a different GPT? Is there a way? Right. Yo. Didn't know all of this was possible. You can connect. What's up with presentation GPT again? Right. Okay, well, looking at each of these summaries. How many did we found? 64. I think. Damn, how can I best do this? Give an example, right? Yeah, alright, fine. $20. Why is it 20? Let me think. Alright. So you don't need that many flashcards, but you want the learning outcomes. Okay. Oops. Okay. How do I remember this? Okay. Hello, Nafi. Just got home, gonna lock in for the exam. Alright, let's go. When it reaches lunchtime, that'll be at 1 today, I'm probably just gonna call it and then do more study offline. The problem is, like, right now, I'm still considering the ways to study. I know, you know, we should just do, but also I want to make sure I'm learning the right things first. So the things that I'm least familiar with, that should be the things that I learn first. So I want to be able to focus on that offline. But with that said, where did I put that? Oh, it's here. Okay. And I gotta be like happy with the lecture specifically. Provide. I gotta say provide context. So I'm just kind of prompt engineering at the moment. Alright, let's see how this goes. Sobel operator taught in that class. There is something Sobel, except I don't remember. We're taught about the Sobel filter. A plan. I'm trying to think of a plan right now. Because most of this requires me to remember. All I gotta do is just remember. And I think what's best for me is to prioritize what to remember. So we're gonna put a priority. I'm gonna say this is CNNs are like almost the thing to understand, but I'm just gonna put maybe 4 and 5, 6 and 7. Even if I put a priority on those, it doesn't necessarily tell me much. But regardless, I have to put a priority and then I have to also try and compute. You got 1,000 lecture slides. 1,000 lecture slides to look through. Chances are you probably can't. And so the best way is to look at these questions, understand these well, as much as you can, and at worst, there's 17 topics. If you do 9 every day, it should be fine. There's 17, there's also maybe 6 per day. But 9 per day is the ideal. We will try to do that. Okay. Best bet for me now is to let me see. Yeah, no. It has to be my exam paper still. Bhargav. My LinkedIn's in my description. Epic. Alright. Exam paper. I gotta be convinced with all of this. This is like the main important part. This is the biggest hint in the world. Now, I really wonder what is the outcome of today? What is the possible outcome of today? Bhargav, so your daily streams are great, motivates me to get into academics. Hell yeah. Let's go, man. I'm gonna be ending it early though today, because I got something else later on to do. But, you know, until lunchtime, we will stay online. Problem is, we need to, reevaluate. Let's have a look. I'm gonna pull this now. That'd be a last one. That'd be like the final thing. Alright, you know what? We make a final list. Is that possible? One sec, give me a sec, I'll be right back. Okay. Practice exam revision is probably the most important part. I can probably get a solid 80% of understanding if I just follow the exam. And then the rest is easy. All right, that's the plan. That's what we're going to do. That means this is the exam. This is the one that we're going to look at. And then any extraneous reviews are... An extra review is just there. I'll see you in N. Explanatory. Alright. So Bargov. So you're thinking about how I should, making a video about getting into University of Melbourne. I don't think I will, but I will say, because my advice here is, for me at least, I was a domestic student, and it's been a while since I actually, even went through the process to get into University of Melbourne. But it was, for me, actually quite easy, personally, because I was both a domestic student and I did pretty well in high school. So the problem is, I don't think I have enough knowledge to tell you, what's best or how to get into the University of Melbourne here as an international student. I'm sure there's other videos out there that will probably give better advice than I would. Hopefully that sets the record straight. Is there any exam to get into your uni? Well, for me at least, there was the ATAR exams, not necessarily university-specific exams. The ATAR exams were the Australian equivalent of I don't know, when you graduate from high school, they're the score you get, and I was just among the top 8%. Right, so I was the top 8% of students, and I was able to make it into Melbourne Uni. Now, it's still I don't know what it's like for the others. So I don't know what it's like for international students actually. Right, so unfortunately. Okay, anyway, let me know of any other questions before I head off. I'll be heading off in just a bit for lunch. And then, the plan is I'll be doing other stuff, but offline. So I can get more focus, but also, I think I need more intermittent breaks. And I might go out for a walk and then I might be back. No, don't be sorry about that, man. All good. All good. Let's just check some emails maybe. Just give it a break. Okay. Annual host plus. GitHub universe. Okay. Don't need to bother with. Okay. All right. I'm gonna have lunch now. So yeah, I'll catch you guys. I'm gonna say after exams because I'm gonna be fully focused within the next few days to revise all that I can, and then also do the exam. And then after that, you know, we're talking next Tuesday. I should be good. I should be good to come back online. All right. So I'm gonna call it a day. It's been a shorter one today, but yeah. I'll see you next week, Nafi. Thanks for joining in, and thanks for sticking along. All right. I'll catch you guys next week. Peace.